This video is about sets. So we're going to talk about first set notation. A set is a collection of numbers or objects. If you think about a set of golf clubs, that's a particular number of different golf clubs in a container, in a group. You can think about a chess set has all the different pieces that you need in order to play chess. So a set is just a collection of numbers or objects. When we write sets, we include them in these brackets, and they're separated by commas, and usually the set is given a letter title, usually a capital letter title, and it doesn't have to be, but often it's a capital letter. Sometimes it's a Greek symbol or some other sort of symbol. The numbers or objects in the set are called the elements or the members of the set. So if we look at this example here, this is the set of all vowels, and so A, E, I, O, and U are all considered members of that set. We use this symbol here. It's like a little sideways E. So if I'm drawing it, I usually draw a C and then like put a line through the middle of it. And it stands for an element of the set. And then if you put a line through it, it's not an element of the set. Just like an equal sign stands for equals, and then this symbol stands for not equals to. So for example, in this set A, we have the numbers 1, 2, 3, 4, 5, 6, and 7. Therefore, 4 is an element of set A, but 9 is not an element of set A. That's because 4 is inside the set and 9 is not. There are some special number sets out there, and we've talked about these at the beginning of the year, but N, which is the set of natural numbers, so it's going to be 0, 1, 2, 3, 4, etc. Integers, that's given a Z, and that's 0, 1, 2, 3, 4, and then all the negatives. But you can also split the integers into just positive integers, so that's Z with the little plus, or negative integers, which is just Z with a little negative. We also already talked about Q. That was the set of rational numbers, so anything that can be written in the form of a fraction. So those are things like 1/2 or 0.5, anything like that. R was the set of all real numbers, and those are the numbers that can be placed on a number line. And then positive R would be all the positive real numbers, and negative R, or R negative, would be all the negative real numbers. So far we know what a set is, just a group of numbers. We name it with a big capital letter, and we list the elements inside brackets. If you want to know how many elements are in your set, you can ask for this. So this notation means what's the number of elements in set A. So for example, that's given here, we have 1, 2, 3, 4, 5, 6 different values. And so therefore the number of elements in set A is equal to 6. This is a finite set, meaning it ends. You can have infinite sets, which means they go on forever. If we go down to where it says subsets, a subset just means that it's part of the original set. So our example here, this says the set that contains 2, 3, and 5 is a subset of the set that contains 1, 2, 3, 4, 5, 6. So every element in this first part is found here, 2, 3, and 5. Okay, also, so some other key important words are union and intersection. And you can read their definitions here, which you definitely should. A union is going to be all of the members in both sets, and an intersection is just the members that overlap. Disjoint sets means that they don't have anything in common, so there's not subsets. Okay, so here's our first example. Say we have the set that contains the values 2, 3, 5, 7, 8, and 9. And we have a set of M, which contains 3, 4, 6, 9, and 10. So first, is 4 an element of M? So they're basically just asking, is 4 inside that set? It is not. Therefore, that is false. Next, they say 6 is not a member of M. So is 6 a member of M? No, it is not. So that statement is true. Then they ask us to list the set. So M, this stands for intersection. N, intersection is where they have things in common. So the numbers that they have in common are 3. So they have 3 in common and 9 in common. So 3, 9, that would be the intersection of those two parts. If I was asking for the union is just going to be all of the numbers. So M union N is going to be equal to 2, 3, 4, 5, 6, 7, 8, 9, 10. And you only write them once. You don't have to write them more than once. Cool? All right, last, M is a subset of N. So are all of the values in M contained in N? No. Is 963 a subset of N? Yes, it is, because all 3 of those values are contained. Okay, so that's the information on sets. It's a lot of vocabulary, so make sure that you go read through.